A very good morning to all. So, in this session, we are going to see about the Unit 3 concept. So, the Unit 3 consists of association rule and classification. So, the association rule, it describes about the association between the product and frequent items purchased. So, through the third unit, with respect to of association rule, the APRI algorithm is very important. The second half is deals with the classification. The classification is comprised of decision tree and naive Bayes algorithm. Along with that, we are going to see about the back propagation. So the back propagation is a neural network learning algorithm. So in that we have a number of units like input, output, and also we have another unit called hidden unit. So generally, we defined a neural network is a set of connected input-output units in which each connection has a weight associated with it. So the neural network learning is also referred to as a connectionist learning due to connections between a unit. So this is a multi-layer feed-forward neural networks. So here you can see the first in the left hand side, from the left hand side, it is a input layer, and in the middle layer is called a hidden layer, the output layer. So the input layer, the output of input layer is given to the hidden layer. The hidden layer output is given to the output layer. Then output layer gives some results. So the back propagation algorithm performs learning on a multi-layer feed forward neural networks. It iteratively learns a set of weights of for prediction of the last labels of tuples. So it consists of the multi-layer feed-forward neural network consists of an input layer, one or more hidden layer, and output layer. So each layer is made up of units. The input to the network correspond to the attribute measured for each training tuple. The inputs are feed simultaneously into the units making up the input layer. These inputs pass through the input layer and then weighted and feed simultaneously to the second layer of neuron-like unit known as hidden layer. The output of the hidden layer units can be input to the another hidden layer and so on. The number of hidden layer is arbitrary, although in practice usually only one is used. So what is the meaning in that? When we are using back propagation concepts with the neural network thing, so you have an input unit and output layer. So in between you will have a hidden layer. So there is no limitation for restricting the hidden layer, but in a practice you can use only one neural hidden layer for your operations. The weighted outputs of the last hidden layer are input to the units making up the output layer, which emits them network's prediction for a given tuple. The units in the input layer are called the input unit. The units in the hidden layers and output layer are sometimes referred to as neuroids due to their symbolic biological basis or output units. The multi-layer neural network has a two layers of output units. Therefore, we say that it is a two-layer neural network. So you can see this diagram. So here it gives one output and this gives another output, so that it is called as two-layer neural network. So generally the network topology, the user must design on the network topology by specifying a number of units in the input layer, number of hidden layers, and the number of units in the hidden layer and the number of units in the output layer. So number of units in the sense the x1, x2, x3, xn. So these are all the units. So we need to decide these units for when you're going to design these things. So typically input values are normalized as to fall between 0 to 1. So the values given to the input unit is from 0 to 1. The network design is a trial and error process and may affect the accuracy of resulting trained network. So now we'll go with, so till now we discussed the general arrangements of units. Now we'll go with the detailed process of back propagation. So back propagation learns by iteratively processing a data set of training tuples, comparing the network's prediction for each tuple with the actual known target. So when we have some set of our known values. So the inputs are given to the particular input a hidden layer and output layer. So finally, the output layer gives some prediction value. So when we are going to compare the prediction actual value and the target value. If it is matched, then we achieve the results, or otherwise we may classify the particular data. So the target value may be the known class labels of the training tuple or a continuous value for a prediction. For each training tuple, the weights are modified so as to minimize the mean squared error between network's prediction and actual target value. So these modifications are made in the backwards direction, that is from the output layer through each hidden layer down to the first hidden layer. So initialize the weights. So this is the first thing. The weights in the networks are initialized to small random numbers, -1, 2, +1, or -0.52. Each unit has a bias associated with this. And so each training tuple X is processed by the following: propagate the input forward. So first the training tuple is fed to the input layer of the network. The input passes through the input units unchanged. That is, for an input unit J, its output OJ is equal to its input value. The next net input and output unit is hidden and the output layers are computed. So likewise, so we already defined that. So here it gives in a detailed steps. The net input to the unit in the hidden or output layer is computed as a linear combination of input units. Each such unit is a number of input to that are in fact the outputs of units connected to the previous layer. Each connection has a weight. So how we are going to compute the value in the sense I of j equal to summation of weights of units. So here the units, input units y1, y2, y3 are input layers, so are given to the input units and weights are combined, weighted sum and added with the bias value, and it is given to the activation function, and we'll find the function. So this is what the data are given as an input to the input unit and classified according to the level from between 0 to 1. Okay, thank you.